17. A sphere of the largest side is placed inside a cubical box of side 20 cm. Another smaller sphere is placed such that it externally touches the first sphere and the three mutually adjacent sides of the cube. Find the radius in centimeter of the square. Okay. We have done such kind of question in square also, right? In square and circle, what happens is you have a circle, you have a square, and you have another circle here, right? So let's say first use this approach and then extend it to cube. Okay, let's say square has the side of 20. Okay, and you need to find the radius of this. So radius of this is 10. So what logic I can use here is, from this to this will be 10 root 2. From this to this we have 10. If this is r, now this is again like this, right? So this gives you r root 2, because the smaller part is also like this, isn't it? Where r, and this is r root 2. So can I say this complete 10 root 2 is equal to 10 plus r plus r root 2, and then solve it further, right, to get the value of r. This happens in square and circle, right? Or what you can do is, you can assume that one more circle here and do it in the full part. So full part, the diagonal will be 20 root 2, should be equal to diagonal, that is 20, plus r here, 2r, plus twice of this, 2r root 2. Okay, that also gives the answer. I mean, it is okay if for better understanding in any ways, right? But now we have a cube. In cube, because it's a 3D figure, we need to talk about the body diagonal of the cube here, right? So I am talking about now this diagonal. So if this side is 20, this is 20 root 3, not 20 root 2. Okay. Similarly, if you follow the same process which we have done in the square and the circle, so in the second part, right, just replace every root 2 with root 3, because the figure will become 3D now. So in the second approach, what we have done is 20 root 3, the longest diagonal, should be equal to the diameter of the sphere, that is 20, plus 2 radius, 2r, plus twice of r root 3. Got it? Now let's solve it further. 2 will be cancelled out, so r is equal to 10 root 3 minus 10 over root 3 plus 1. Multiply this with root 3 minus 1 into root 3 minus 1. Gives you 10 into root 3 minus 1 whole square, that is 3 plus 1 minus 2 root 3 upon 3 minus 1. That will be cancelled out, so that 10 into 4 minus 2 root 3 over 2, or nothing but 10 into 2 minus root 3, or 20 minus 10 root 3, which is option A. I hope this part is clear. You need to visualize, right? I cannot show you a 3D figure here. You need to visualize it's a cube, not a square. That's why I cannot use root 2 here. I have to use root 3. Okay. Some of you might have marked this as option D, none of the above, if you use root 2 here.